Good evening and welcome to Whether or Not. I'm Salix Iverson.
And I'm your co-host, Dan Guzman.
So Dan, we had very mild conditions here in State College for the beginning of this week with high temperatures about 10 to 15, maybe even 20 degrees above average for this time of year.
Yes, we did have some very pleasant weather. Highs were in the 60s and even up to the mid 70s on some days. But Allison will have some more details on that later in tonight's episode.
I also have two stories this week, one about record-breaking heat in Phoenix, Arizona, and the other about weather-related power outages.
I will also be doing a story on how China could be carbon neutral by 2060 and the fact that NASA gets its first ever taste of an asteroid. Ruch will also have a feature tonight on El Nino versus La Nina's impacts on the winter season.
But first, here is Nature in the News. Last week, Phoenix, Arizona set a record for the number of days with high temperatures above 100 degrees Fahrenheit. With records dating back to 1896, Phoenix tallied a total of 145 days of triple-digit highs, which breaks the previous record of 143 days set back in 1989. This also means that in Phoenix, half of the days so far this year have had a high temperature above 100 degrees Fahrenheit. According to Climate Central, summer temperatures in Phoenix have increased 3.5 degrees Fahrenheit since 1970. Typically, the North American monsoon season, which spans from June 15th to September 30th, gives many in the southwestern region of the United States a relief from the heat. However, this year, due to persistent high pressure aloft and a lack of moisture, the monsoon season was abysmal. The average rainfall totals during the monsoon season in Phoenix range from 2 to 4 inches, but this year, Phoenix only received 1 inch of rain. Thankfully, high temperatures will begin to decline as daylight begins to decrease.
China has made an ambitious pledge to be carbon neutral by 2060. The world's largest emitter of carbon dioxide has also vowed to begin cutting emissions within the next 10 years. Plans to achieve this goal include switching to only electric vehicles, using zero-emission electricity methods, and by planting trees. By 2060, China will need to produce around 15,000 terawatt-hours of electricity, over double what it is now. This growth will also be powered by an enormous ramp-up of renewable energy sources like solar panel and wind farms. New technology to capture carbon dioxide from fossil fuels and put it underground is currently being developed as well. With final details still being put into place, the plan for decreasing the amount of greenhouse gases includes continuing to increase emissions until 2025, letting them plateau for about 5 years, and then steeply decrease them to net zero by 2060.
Late this summer, Hurricane Isaias left millions in the Northeast without power for days, with Hurricane Laura and extreme heat in California contributing to many more power outages just this year. An increase in extreme weather events is just one of the consequences of climate change. Climate Central analyzed 20 years of power outage data and found a 67% increase in major power outages, which they defined as 50,000 or more customers without power. Michigan ranked first out of all states, and the District of Columbia, with a total of 111 major weather-related power outages. Texas was not too far behind, with a total of 105. Here in Pennsylvania, we had 71 power outages over the last 2 decades, with the most occurring in 2011, where we had 10. The regions of the United States with the greatest increases in power outages were the Northeast and the Southeast. Climate Central also discovered that power outages can cost the United States up to $33 billion annually. It will be interesting to see how this data may change in another 20 years from now as climate change continues to impact our society.
On October 20th, 334 million kilometers away from the Earth, NASA's OSIRIS-REx briefly touched down on the surface of an asteroid named Bennu to collect samples. Launched in 2016, the $800 million spacecraft is NASA's first ever asteroid sampling mission. Previously, asteroids could only be understood by studying meteorites that have fallen to Earth. Being able to scoop up dust and some pebbles offers just a small glimpse of the universe's formation over 4.6 billion years ago. Scientists hope to retrieve at least 60 grams of samples when the spacecraft returns to Earth in March of 2023.
Good evening. I'm student meteorologist Allison Gutleber here with your Central PA forecast. Mild and dry weekend ahead with a chance of rain before our first Penn State football game of the season. So let's look at our maps. State College, fairly dry for the day. On Friday, we do have a warm front above us, but we will be seeing that cold front move in towards the east, bringing us showers either Friday evening or into Saturday morning. So that would be before our game. But as it moves off into Sunday, we will see maybe a possible chance of rain in the western portion of the state, but it will get colder for sure on Sunday. For Friday, we do have higher temperatures, 73 as our high, mostly sunny conditions, and that will be above average for this time of year. For Friday night, we will go down into the 50s, 55 as our low and cloudy conditions, here to stay into Saturday, which will be the first game, 3:30 kickoff. Our temperatures will go back into the 60s, 65 as our high, but we will see those cloudy conditions stay. But it is the first game day, so we won't let that get us down. Into Sunday, we will have some colder conditions, 53 as our high, but that sunshine is here to stay. Next, we have a feature by Joe on how El Nino impacts winter weather.
What if I told you that the environmental conditions in the equatorial Pacific Ocean had a significant impact on our weather here in the United States? Well, in fact, it does, and it all depends on the El Nino Southern Oscillation.
The El Nino Southern Oscillation is an ocean atmospheric phenomena linked to warming or cooling of the equatorial Pacific Ocean. It typically occurs over 3 to 7 years, and the water either warms or cools 1 to 3 degrees Celsius, depending on the strength. This equatorial zone refers to the ocean between South America and Australia. The El Nino Southern Oscillation is comprised of 3 positions: El Nino, La Nina, and the neutral position. In order to detect the current phase, many methods are used, such as satellites, buoys, drifting buoys, sea level analysts, and expendable buoys. Many of these ocean observing systems were part of the Tropical Ocean Global Atmosphere Program, or TOGA, and are now evolving into an operational El Nino Southern Oscillation observing system. NOAA also operates a research ship which is dedicated solely to servicing the Tropical Ocean Atmosphere Network component of the observing system. The oscillating warming and cooling patterns directly affect rainfall distribution in the tropics and can have a very strong influence on weather across the United States. An El Nino occurs when above average sea surface temperatures dominate the central and eastern Pacific Ocean. This results in reduced rain over Indonesia and the ocean. The shift eastwards in above average ocean temperatures shifts the jet stream east, favoring low pressure over the Gulf of Alaska, with higher pressure over western Canada and low pressure over the southeastern United States. These changes can have a very big impact on the weather that we will experience during the winter time in the United States. With winter approaching, some general atmospheric patterns have been identified under a typical El Nino. Under an El Nino, 4 prominent changes in the wintertime with the atmospheric flow across North America and the northern Pacific are identified. The first change involves the eastward extension of the East Asian jet stream from the international dateline to the southwestern United States. Next, there is a more west to east flow of the jet stream with winds across the United States than during a typical year. The third is a southward shift of the storm track from the northern to the southern part of the United States. The final change is a southward and eastward shift of the main region of cyclone formation west of California. These large-scale changes result in exceptionally stormy winter weather and increased precipitation across California and the southern United States. However, less stormy conditions are present in the northern part of the country. On top of that, there's an enhanced flow of marine air into western North America and a reduced flow of cold air from Canada. This will lead to a mild winter across the northern states. La Nina can be identified as the cold phase of the El Nino southern oscillation. The pool of below average water temperatures shifts the area of above average water temperatures westwards towards Indonesia. The jet stream responds by pulling back towards Asia. This causes major circulation downstream of the jet. Higher than average pressure dominates the Gulf of Alaska, with lower than average pressure over the western United States and Canada. In result, high pressure dominates the southeastern United States. These large-scale modifications lead to three prominent changes in the wintertime flow across the eastern North Pacific and North America. The first change is an amplification of the climatological mean wave pattern and an increased meridional flow across the continent. The second is an increase in blocking activity over the high latitudes of the eastern North Pacific. The final change is the inconsistent strength of the jet stream over the eastern North Pacific. These conditions lead to a large portion of North America experiencing increased storminess, precipitation, and an uptick in cold air outbreaks. Meanwhile, the southern states will experience less storminess and precipitation.
Better predictions of potential climate episodes such as floods and earthquakes could help save the United States billions of dollars. Predicting the life cycle and strength of a Pacific warm or cold spell is the first step to help avoid or mitigate these risks.
I'm back with our extended forecast. It's going to be the last we see of the 70s for a little while because we have below average temperatures continuing the rest of the weekend and into next week. For our weekend recap, Friday, mostly sunny conditions, our high of 73 and our low of 55. Saturday morning, we have possible precipitation. We'll have temperatures in the 60s, a high of 65, and our lows will dip down to the 40s. Sunday, we'll have sunshine all day, but it will get a little chillier, 53 as our high and our low of 45. For our extended forecast, lower temperatures will be arriving. On Monday, we'll have partly sunny conditions, above average temperatures. Tuesday, we'll see a little bit of rain possible and still above average temperatures. But Wednesday, throughout the rest of the week, we will have below average temperatures. Wednesday, a little bit of rain. Thursday, partly sunny conditions. Friday, cloudy conditions, but we will have a high of 48 on Friday. Back to you guys at the desk.
And now back to our Weather Whiz Quiz question. Since 1970, how much have summertime temperatures increased in Phoenix, Arizona? Is it A, 1.5 degrees, B, 2.75 degrees, C, 3.5 degrees, or D, 4 degrees? And the correct answer is C, 3.5 degrees.
Yes, temperatures have increased dramatically in Phoenix, Arizona, and some local residents believe it to be due to the urban heat island effect from the drastic growth of the actual downtown and urban areas in Phoenix. I can tell you that when I lived there this summer, we broke a lot of high temperature records as well as warm low temperature records. But a lot of people say that it is a dry heat.
Yes, a dry heat is always better than when it's hot and sticky out with those high dew points. I couldn't imagine being in temperatures over 100 for longer than just a few days. I don't think anyone else could.
Well, that's all the time that we have for tonight. Thank you for watching Whether or Not, and we'll see you next week.